looking at the 2017 questions, and the first one has this class called digits. So I have another example here of a user-defined class. In this case, there's an instance field belonging to it that's an array list of integers, wrapper class integers. It's called DigitList. You'll notice in part A, we're writing the constructor, same name as the class, no return type. So gotta remember, main job of the constructor is to initialize instance fields. DigitList has only been declared. So first thing I'm going to do is I'm going to say DigitList equals new array list of integers, and then that way I will have actually initialized it with an array list. And then at that point, they're going to give me some rules for how to go ahead and put some values into it, and then I'm going to answer if it's strictly increasing. That's kind of a classic algorithm we need to know. All right, so they give me a number. They want me to break it down by its digits. This is another common algorithm that we're expected to know. So the best way for you to do this, I know you can try to convert it to a string and stuff, but really you should be using modulus 10 and divide by 10, in my opinion, to break this digit apart. This works probably best with a while loop because we don't know how many digits there are going to be. So we'll just kind of let it run while there's digits remaining. Modulus 10 will grab the last digit from the number, and then divide by 10 will eliminate that digit. We'll just do that once for each digit. Supposed to be a little careful. If we're not, we might reverse the order of the digits as we put them into the array list. So every time I put a digit in, if I just hit the add method, like they'd all go to the end, and since I'm getting the 4 first, the 0 would go after it, and then the 7 would go after that, and so on. So I'll add everything that I find to the front of the existing list to preserve the original order. And it's interesting that they showed us this example too with digits 0. If we're not careful, we might miss that. We might create an empty digit list of size 0, which is different than this digit list. This digit list is implying it's size 1, and it actually shows a 0 in it. And depending how you write your while loop, that probably wouldn't happen by default. Okay, but before we even worry about the while loop, don't forget, this is a constructor, and so the very first thing we need to do is initialize an array list of integers that belong to it. So we go to the array list constructor and construct one. At that point, I can start worrying about my while loop. Now, most of us would probably write this while loop along the lines of while num is greater than 0. That could pose a little difficulty, and I'll show you why in just a second. Okay, as I mentioned before, we can isolate the last digit of any integer by taking its modulus with 10. Okay, we want to add that last digit to our digit list. So I'm going to ask DigitList.add. However, like I mentioned, if I just added it, since I'm going across the digits from right to left, and they're adding to the end, this would actually end up reversing the order. So I'm going to keep adding the digits that I find into the front. So like with their example, okay, the 4 would go in first, the 0 would go in front of that, the 7 would go in front of that, and so on. So this is going to give me the proper order. And then I'm going to take num and divide it by 10 to throw away one of those digits. With integer division, okay, no decimals, you keep dividing by 10, eventually that number is going to hit 0 and your loop's going to quit. All right, but here's the catch. This said while num is greater than 0. What if they gave me num equal to 0? And notice, precondition, num's going to be non-negative, but it might be 0. My while loop would not actually handle that. So I would actually end up with a size 0 digit list. Nothing would have been added to it. This is probably most easily addressed by just simply saying right off the bat, if num equals 0, go ahead and add it to the digit list. And it wouldn't really matter where we add 0 at that point, okay? So just go ahead and add it. You could put the word else here, but you don't really need to because the control of our while loop only runs if it's not 0. So it has to be greater than 0. So if it is 0, that's our special case. Any other number that comes to us, there's not going to be any negatives, so we don't have to worry about the positives. should be addressed through this procedure. And it doesn't matter if we destroy num because we're only handed a copy of it anyway, right? It's a primitive, so we're not given its memory address. And got to put in a return here. Let's just put return false temporarily. We'll fix that in a minute. And let's see if we're getting a digit list like they mentioned. Now notice, like, see right here, that 0, okay? If I had not included this special case, my code would have run, but you'll see for yourself, it's gonna give me an empty array list. So this was an intended trick by the College Board. I mean, probably ruined a lot of perfect papers, I would imagine. So I bet a lot of kids, didn't catch that. And it was kind of subtle. And then if you didn't put this 0 here, okay, like I mentioned, watch how the digits reverse. We won't have 15704. We're going to have the reverse of that, 4751, when we should have gotten 15704. Okay, so that's why we needed to make sure to add that index in as to where we wanted it. All right, now, are the digits in strict increasing order? Okay, strictly increasing. You got to play by their rules. Okay, a lot of times students want to talk to me after I hand back a test or something and say, well, I thought it meant this. Well, it doesn't matter what you thought. I mean, this is what they said it is, okay? So this is their definition. The first is greater than, but not equal to the preceding element. Okay, so ties don't count here, right? So like right here, 3, 3, that's not considered strictly increasing by their definition. Anytime you want to start comparing things within some sort of storage system, whether it's an array or a list or even a string, you always have to be very careful of going out of bounds. So as I write this code, if I just wrote a typical loop, and I don't think I would use an enhanced loop because I want to have the indexes to let me compare. Although you could use an enhanced loop and you could even store like the previous value somewhere, but this is fine. So I'll go from 0. If I went all the way across the array, so digit list dot size, likely I'll go out of bounds depending how I write the rest of my code. So let's leave that now, and then we'll come back and change it. Okay, so now how do you want to do this? Do you want to, I should say 4. Do you want to take the previous value or the value that comes after it? It's 100% up to you. So if you wanted to say that this one was digitlist.get I minus 1, okay, then you better start your loop at 1 as opposed to 0. If you wanted to put I there and put I plus 1 on the right, that's fine also, okay? But then you should stop your loop 1 early. Does not matter, okay? What we want is this, right? We want the number on the right to be greater than. We want that to happen every time. So if we were going to write code this way, we could set up like a counter and then let the loop finish and then evaluate the value of the counter. Or it's easier, I think, to just look for one counter case. If I can find one counter case that doesn't meet their definition, so it's not strictly greater than, then I know that it's a false list. Okay, if I find one case to the contrary, that's enough to say, you know what, this was not strictly increasing. And I'll just go ahead and say false. The only way I'll consider saying true is if I can make it all the way through the list and never find a single counter example. And so if you look at my test cases, I put in, I think, pretty much the same list they had. I may have put like one extra one in, but okay. So there you go. And 3 trues, 3 falses, looks perfect.